with chapter 3. Most of it has a lot to do with chapter 3, from sampling to data analysis, has a lot to do with chapter 3. Even when doing literature review, you also do literature review on methodology. When there are gaps or when there are inconsistency in literature, whether it's in methodology, that is a gap that you should consider and explore. You also do not want to duplicate what has already been done. That's one of the reasons for doing literature review. You're only supposed to build on what has already been done by identifying gap. Sometimes the gap might look too small, but it is a gap nonetheless if you want to exploit. And the Vice Chancellor has said here that PhD is very, very specific. You have to address a very specific idea or topic, but you cover it comprehensively. Most people these days are going into meta-analysis and quantitative because it is easier to get secondary data as opposed to primary data. And it is easier to do quantitative because most of the things depend on you, one of which is analysis. You do it very thoroughly. So you realize that hypothesis is part of your chapter 1. Just after the research questions, what do you understand by hypothesis? When you already have your research topic, you have your research question, you've done the concept. Whatever it is that you're doing, at the back of your mind, you have a tentative answer to your research question. That is hypothesis, a tentative answer that we call it tentative because you may want, after collecting data, analyzing data, you might reject it, or you might fail to reject it. It is important for any researcher who is doing research to have a rough idea of what they think the answer to the research questions would be. And that forms a hypothesis. It is a rough guesswork of what would be the outcome of this study. So when you are doing your chapter 1, there's a section for hypothesis. You have to align your hypothesis with your research questions, such that when you are analyzing and collecting data around your research questions, the hypothesis will be tested, or your answer might be, your tentative guess might be approved or disapproved. So why do we do hypothesis testing? Why? Many things in our studies are taken for granted. And in critical thinking, we are always supposed to examine, investigate, and not take for granted other assumptions that people have. We are supposed to investigate them. If we take everything for granted, all the assumptions that this is what is supposed to be, we are not thinking critically. But once we have begun to question things, we begin to find the tools to test their validity. One of those tools is hypothesis testing. Now, in qualitative, hypothesis testing is different from quantitative hypothesis testing. Now, after you've done all your literature review, you've done all the data collection in qualitative, you have analyzed your nuanced data in a very scholastic writing, scholastic argument. You arrive at your conclusions that either refute or do not refute your hypothesis. You test it. Now, in quantitative, we collect data, numerical data. We analyze that numerical data. We subject it to tests. It could be t-test, f-test, to either fail to reject the hypothesis or reject the hypothesis. You'll realize that I'm not saying accept the hypothesis or fail to accept, no. And I will explain why we're saying reject or fail to reject. So when we are testing hypothesis in quantitative, we have only two options: reject or fail to reject. But we must have a significance level, 95% confidence level, which is also referred to as 0.05% significance level. Now, perhaps you're wondering, why would we have a 95% confidence level? Why is it that small? I want to give an example. Let me use the criminal system to give an example. You are living in a neighborhood. In this neighborhood, a man and his wife often quarrel. And they quarrel, sometimes they fight physically. Then one day, the wife of this gentleman with whom they fight decides to wake up very early in the morning. Maybe it's a Saturday like this, and go to work and leave this gentleman, who perhaps is a businessman and may not be going to work on a Saturday. Then while this lady is away, and this, the husband could be having maybe heart disease, but nobody knows, suddenly does not wake up. Then the lady goes to her work the whole day and comes back at 9. Find people at her door, that her door is closed, the children are crying, and the husband has not woken up. So she comes and she finds when the police is there, already been called, and they close the door. They open the door and find the gentleman dead. Now, based on this information, if you have that prior information, you definitely know that this lady did not poison the husband, or had nothing to do with the death of the husband. Now, this lady is arrested. Now, assumption here is you don't know anything. I've just given you a background to illustrate. You don't know everything. All you know is that this lady woke up, left the husband. The husband was later found to be dead, the children crying. And so it is suspected that the death is mysterious. He could have been poisoned. So there is foul play, at least according to police. So the lady is arrested, taken to the cell. With the background information that I have given here, we all know that this lady is innocent. But all the evidence points towards guilt. One, they have been quarreling oftenly, and they have been violent with each other. 3, she left early in the morning. She was the only person who was in that house and who left. And this person is found dead while she is away. The other thing, nobody in the neighborhood knew that this gentleman who is hypothetically dead had any underlying condition. And you are the jury. Think about it. If we make the confidence level, the significant level, the level under which we must provide all the evidence and have incontrovertible evidence that this person is not guilty, is 95%. That we must sure, after considering everything, that there are only 0.05%. If it attracts capital punishment, capital offense, now this lady has to be sent to the guillotine or the hanging. It means we must make the level of doubt so little. So understanding the significance level of 0.05, that is the level of doubt that maybe she did it. Now, suppose we made the level of doubt to be 95%, that there's 95% chance that she did it. Very many innocent people would be in prison, sentenced for life, because we set the bar of evidence way too low. Now, that is what we mean when we say the significance level is 0.05%. This is the allowance we give for uncertainty, that perhaps you're going to make a wrong decision. Now, if you give the certainty, the probability of making a wrong decision 50-50, it beats logics. So that is why the significance level is set to be 0.05. Sometimes it will be argued that that is even still too high. Why not 0.01? There is only 0.01% chance that she killed the husband. And therefore, if we are going to execute her, we have considered everything and found this is the case. Now, where is the burden of proof? Now, take, for example, and I know most of us here are involved in gender matters. Take, for example, two boys, and I know, Mila, this relates to Ada, two children, a boy aged 17 and a girl aged 16, are having an affair, God forbid. Then the parents of the girl don't like this kind of thing. Then the time and catch these people in the very act and arrest the boy, then the boy is going to be accused of rape. Although they had consent before doing this, but this burden of proof that this is not rape, because this attracts, let's say, capital offense where somebody would have life imprisonment. And this boy's life is going to be messed up with, spend the entire life in prison. You are the jury. What percentage of doubt would you assign to such a case? In statistics, in quantitative, advanced quantitative, we are assigning 0.05%. That 0.05 chances of being guilty. Now, you understand why we give very minimal level of significance. It is for the good of everyone, so that people are thorough in what they are doing. Now, in that circumstance, we always have what we call null hypothesis and alternative hypothesis. Now, null hypothesis is the tentative assumption or answer about the parameter or the theory. And remember, here we are dealing with numbers in quantitative. We are getting to numbers slowly by slowly, but you must get the background. Then the alternative hypothesis, that is H subscript 1. The null hypothesis is H subscript 0 or H naught. I've seen people writing H0 instead of H subscript 0. And also H1 is instead of H subscript 1. So in most circumstances, now in quantitative, the alternative hypothesis is actually the direct opposite of the null hypothesis, which is why in this case, in the case we just used, the case of a man and his wife, the object of the jury is to find either the suspect guilty or not guilty. Not guilty is the direct opposite of guilty in statistics, not innocent. In statistics, innocent is not the opposite of guilty. Guilty, not guilty. So let's take, for example, we are going into little by little, we're introducing numbers now. For example, testing Nyayo car in fuel injection system, that 7 liters of fuel of car can fill a car for an averagely 100 kilometers. You are aware that during the time of President Moi, there was a project to have Kenya manufacture our own car. The car was called Nyayo Project. So if after all the work is done, then we want to say that according to the injection system, 7 liters of fuel will drive this car for 100 kilometers. Now, our null hypothesis in this case is H naught, the hypothesis. U is the average, that the averagely, the miles equals to the liters that I drive for 100 kilometers is equal to 7. The null hypothesis, the alternative is that it could be less than 7. If we use the kilometers, we'd have said H naught U is greater than or less than 100 kilometers. Or alternative hypothesis, we'd have used the average, which is the mean, symbolized by that symbol you see there, mu, is less than 100 kilometers. So we collect data to either reject that hypothesis that those 7 liters do not drive the car for 100 kilometers, or accept or fail to reject. Another example would be Del Monte fruit juice processing farm states that a packet of mango juice contains 2 liters of the juice. So in this case, the processor claims the null hypothesis becomes either greater or equal to 2 liters. That's what we accept, because we are the customers who drink juice from Del Monte. If they say it is 2 liters, it has either to be 2 liters or more. Otherwise, we would report you to the Bureau of Standards. So, however, in decision-making cases, the merchandise firm rejects the juice if the claim is not true. Now, if we find that the Del Monte juice as claimed to be containing, that packet to be containing 2 liters is not, then we'll be rejecting it. So we either fail to reject when the liters, 1 packet of mango juice from Del Monte contains 2 liters, or reject it when it has less than 2 liters. I have also read a case where in a certain farm, let's say university, the accountant made a mistake where every staff member got $20 each by accident, just like the computer error during the time President Uhuru was the Minister for Finance. There was a computer error. Yes, Victoria, I see you have a question. Go ahead, please.
Thank you, Dr. Professor Shem, sorry. Just in the question of hypothesis, now I'm linking it to my research. Number 1, can you have 2 hypotheses? For example, in my case, one is a behavioral dimension, and the second case is an institutional or let's say policy dimension. So my question is that one is, can I have the 2? And then in the null hypothesis, you have said H, that 0 down there, I don't want to say H0, is not,
It's
yes.
not. Yes,
Yes.
yes.
For example, for hypothesis 1, I've put that where the attitudes and behaviors, they influence participation in community-based waste management. And then hypothesis not, or yes, I hope I've said it well, we say that they actually influence. Then I go to hypothesis number 2. When I'm putting the null hypothesis, will it be H3 or will I put it as H0? And then now the null hypothesis as, I don't know, is it H2 or it has to be H0 and H that one? Thank you.
Thank you very much for that question. You will realize that when you look at your research question, each is attached, each is aligned with an objective. Now, if you form an hypothesis around waste management, and you have H naught, that the waste management ABCD. The alternative there will be the opposite of that. So when you form another objective, you might have H naught. It also have H naught and HA or H1. So if you have 3 or 4 hypotheses, and after every aligned to every object, it has to be H naught and H1, or H naught and HA, where A means alternative hypothesis, because you will be testing them individually, not collectively. Hypothesis is being tested individually, not collectively. If you have objective 1 and you form the hypothesis about it, it is tested independently, not in relation to the next objective. I don't know how that.
Thank you so much. Thank you so much. Okay.
So in quantitative, it is a lot simpler.
I have a question, please.
Go ahead, please.
Thank you, Professor. I wanted to find out, and I want to relate this to the work we are doing.
Yes.
Because what you're saying so far, I'm understanding. I just don't know how to extrapolate it. Let's assume that my hypothesis,
yes,
is that involvement of members of parliament in CDF is what makes it work. So how do you extrapolate it to this?
Now, if your null hypothesis is that the involvement of members of parliament in CDF committee makes it effective, then your alternative hypothesis is the involvement of MPs in CDF committee does not make it effective. Is that simple?
So my question is,
yes.
So why don't we just leave it at that? Why am I putting this H what Nini? I mean, I'm sorry for being simplistic, but I think statisticians, you like making life difficult. Why can't I just say that it's as simple as that? Why am I putting H, what, these funny things?
You see,
and then how do I then, what am I putting in this H, what do you call this 0?
H naught.
H naught.
And H1, yes, yes.
Yes, so this naught, is it a number? And if it's a number, okay, what am I exactly measuring? And how am I measuring against what?
Okay, this is what it is. In every discipline, if it is in communication and media studies, or when journalists have language they call journalese, and then in law you have legalese. In statistics, to make this thing easier, we call null hypothesis to be H naught. H naught means H, that naught is zero, H0. The assumption before doing research, more like a baseline, H naught. So if there's a deviation, it will be H1 or H alternative. So if you're measuring, you're saying that the involvement of MPs in CDF committee makes it effective. And your alternative hypothesis is that involvement of MPs in CDF committee does not make it effective. Now, you collect all the data. Let's say, for example, you go to every 30 constituencies and you have your field, your questionnaire. One of the question is, does the involvement of the MP make this the work of CDF effective? You collect all that data. Maybe you have 201 or 50, 100 respondents. Some of them say no, some of them say yes. So when you come to analyze your data, and in quantitative, descriptive, which you learned here, you find that 70% of the respondents actually perceive that the involvement of MP in that committee makes it effective. Then the other 30% say that the involvement of MPs do not make it effective. Then given the numbers that you have, it means the involvement of MPs make it effective. So that's why our HA, or H1, the alternative hypothesis, says the involvement of MPs in CDF committee does not make the CDF effective. The other one is the involvement of MPs, that is H0, makes the CDF effective. So in this case, we fail to reject the null hypothesis because overwhelming number of respondents believe that involvement of MPs in the CDF committee makes it effective. So we fail to reject null hypothesis.
Maybe the question, and thanks, yes. That far you've explained very well. I think even by explaining the knot, now I understand that knot is not of NAUGHT, nothing. So it's a baseline, which is good. Yes. I think it makes sense. But what I'm asking is, let's say we went and interviewed 500 people.
Yes.
And the 300 support the role of MPs, and 200 do not, yeah?
Yes.
So in this H naught, then that funny thing, greater than 2. Put for me the 300. Where is the 300 coming in?
Use
where is the 300? Where do I put the 300 and where do I put the 200? And what am I calculating?
Let's say if you are considering you are interviewing 500 people, and you have set a limit. This is tentative. This is purely on a quantitative research. Purely, this hypothesis here is purely on a quantitative. Now, what you are doing is on mixed method research, where we mix quantitative and qualitative. The hypothesis in qualitative, in this mixed method, how we state it, we will come and write, remove all the mu and 2 equals. No, we just come and state it, H naught, and that full colon. The involvement of MPs in CDF committee makes CDF effective. That is H naught. You can come and delete all the mu and less than and 2, and say H1, which is the alternative hypothesis, the involvement of MPs in CDF committee does not make it effective. The only difference between H naught and H1 here is the word not. So if H1 in the mixed method, you say you write H no subscript 0 or H naught, full colon, and you write the involvement of MPs in CDF committee does not make the devolved fund effective. Then you come to H1, which is also referred to as HA. It's an alternative hypothesis, right? HA, that full colon, and write the involvement of MPs in CDF committee does not make the devolved fund effective. That is how to write it in your chapter 1 there. And all, yes. So after you've got that, yes, go ahead.
I think I understand you. I hope I do. And the way I will understand you is that this is the justem generis of statistics. Yeah, you're just trying to teach us, yeah. But I understand you. Yes, just the way lawyers like writing a justem generis when they could just say something simple.
Yes. That is the legalese, which makes you more professional. But we are reducing this to a level where people can engage with quantitative in a manner that they see their environment. Now, let us talk about type 1 and type 2 error. And let us go back to our case of a dead spouse, husband, in the morning when the wife was away at work. After what we know ourselves, the jury does not know. Now the jury goes in there to listen to this case of the lady, the accused. Now, in the back of our mind, as we know that this lady is innocent, is not guilty. Now, if the jury goes ahead and finds this lady who did not kill the husband guilty, that is type 1 error. The type 1 error is you reject the null hypothesis when it is true. It is like punishing an innocent person. That's type 1 error. You reject the null hypothesis when it is true. that all of us know that this lady did not kill this man. But maybe the legal team of this lady did not do due diligence to provide compelling evidence to prove this lady not guilty. Or maybe the prosecutor did an excellent job that convinced the jury that the accused is actually guilty. Then us who know what happened, we see that the jury has actually found this accused, this lady, guilty. That is type 1 error. We are punishing the innocent. Now that is why we set the significance level to be too low, 0.0, a probability of 0.05. Can you imagine the kind of injustice that is done there by just finding an innocent person guilty? So we fail to reject the null hypothesis.
Professor, can I ask again? Sorry for asking.
Go ahead.
Yeah, just treat me as a person in class 1 in statistics. I wanted to, I'm just wondering, under what circumstances would we have a rejection? Would it be the researcher in the face of, say, proof? Like I can give an example that if I did the example I'm giving of CDF, if I did an interview with the people in urban centers like Nairobi or the elites, then I will get the H1. Yeah, I will not get my H naught. I will get the H1. So is it that if I discover these are just very brilliant but ignorant people, do I then go to my, I insist with my O, or how does that error occur? Is it from the researcher or who does the error?
Yeah, mostly it is the researcher here. The reason why I'm explaining this is just for your understanding of what is type 1 error and what is type 2 error. Now, in your case, after you have collected data from your respondents and you found an overwhelming number responding that they believe when MPs are involved in the CDF committee, the devolved fund becomes effective. Then you ignore all that and decide on the alternative, which says that the involvement, that is H1 or HA, that the involvement of MP in CDF committee does not make the devolved fund effective. That is type 1 error. But it is not easy to get into type 1 error with quantitative because we analyze it quantitatively and do the tests and find that the numbers here are more than the numbers there. And therefore, we fail to reject null hypothesis, which we find out that the involvement of MPs in the CDF committee makes the devolved fund effective. On the other hand, if after you've collected all the data and did your analysis and found an overwhelming majority believe that the involvement of the fund, of the MP in the devolved fund, the CDF, does not in capital, does not make the devolved fund effective, you reject the null hypothesis, H0, which said the involvement of the MP made the devolved fund effective. So that is how you reason with null, with the hypothesis. So we will go into testing that is now the mixed method kind of testing. The quantitative method of testing.
Professor Sam, I have a question.
Go ahead.
I understand, the two types of errors, but was just wondering, in your experience, do you see that in quantitative studies, scenarios like the Hawthorne effect, where...
Please go ahead. I've lost you.
A question. Sorry, can you hear me?
I can hear you.
Awesome. Do you think that the Hawthorne effect or similar situations that happen in research environments can actually determine whether a researcher could inadvertently end up in a type 1 or a type 2 error?
Yes, a researcher may end up in a type 1 or a type 2 error if, one, the analysis is faulty, which means the method used, even if it is quant, the method used could have been faulty. That is one. Or if the researcher, in this case, failed to interpret correctly the hypothesis that they're dealing with, they're trying to test in the research. Under those circumstances, you will find there's a possibility of committing type 1 or type 2 error. It is the objective of this lesson today to make you understand what really constitutes type 1 error and what really constitutes type 2 error in this case. Charity, you have a question. Go ahead.
Yes, Prof. I was just wondering, when you're looking at type 1 and type 2 errors, in the example given, I'm wondering which is the worst error. What are we calculating and what next? I mean, I'm just wondering that. Yeah.
That's a brilliant question. Thank you. Let us go back to our question, our example. Between type 2 error is this person really killed the husband and we are setting her free. That is, freeing a guilty defendant. Which one is greater? Punishing an innocent person or freeing a guilty person? Now we got into what we call philosophy of hypothesis. What really are we trying to do for the society? One, we understand that when people are institutionalized, whether it is the children, the Boston institutions, or it is just the normal jail for adults, they are called correctional facilities. And this is also feeds into the debate of a death sentence. Should we really kill those people? Is it a punishment or a correction? Is death a punishment or a correction? Or are we correcting the larger society by killing one person? No. If you release, if you fail, if you punish an innocent person, in this case, vis-a-vis freeing a guilty person. A guilty person may say that after what I've seen, I cannot do this again. They are reformed. They don't want to go through that. Now, take it in the case of a death penalty. Now you are going to kill an innocent person and freeing a guilty person. A guilty person may change. An innocent person is gone for good. A case in point, there's a precedence in this. The very first person to have been electrocuted in the US was a black child, I think aged 13, who was accused of rape. Very innocent. It was proven way, way, way later, maybe after 50 years, that this child was actually innocent. But now they are dead and gone. Maybe who actually raped that girl for whom this boy was killed, later reformed, who knows? But the guy is gone. It is for this that we make it difficult for us to commit type 1 error. Type 1 error in the philosophical scheme of hypothesis is a more serious error, like in this case. If you ask me, looking at the philosophy behind hypothesis testing and forming, the type 1 error, we must make it very, very. Take, for example, good. Thank you for asking that question. Take, for example, I'll give two cases in medicine. One, the vaccines. After doing all the clinical trials, and then there is the placebo, and there is also the treatment. And we will cover this in ANOVA, when we're handling ANOVA. Now, this drug, let's say this vaccine that is being used, this hypothetical situation, causes cardiac arrest. And during the clinical trial, you gave it a significance level of 50. That there's a 50% probability that it will cause cardiac arrest. Then when people will be at the airport, or they collapsed, or somebody will, or they collapsed. Then compare that we set our significance level at 0.5, not 0.05. The probability of somebody having adverse effect after using this vaccine is half. Would you use that vaccine? You won't. So that is why type 1 error must be taken very, very seriously. Now, take, for example, the HPV vaccination that presently is going on in primary schools, where girls aged in primary school are being vaccinated against cervical cancer. If there is no clear clinical trial which establishes that there are zero adverse effect into the future of this 13-year-old girl, or 7 or 10 in the future, that this will not interfere with their fertility later, that this will not interfere with their health later, then there is no such kind of research and data that is given before my country accepts that these people this HPV vaccine must be given mandatory for girls in basic education. It means we are committing a fundamental crime, moral crime, to the future of our country, the future of our kids. So we set the significance level to be too small. In fact, in that case, actually 0.01. That we only want to have 1% chance that any girl in school-going age is vaccinated with HPV will not have adverse effects in their future, because we are looking at the future. Now, it is important before passing policy on vaccination to ensure that we have the data from clinical trials that demonstrate that there is a 99% chance that any child vaccinated with HPV will not have adverse effect. This will not interfere with their fertility. This will not interfere with their cardiac system. This will not interfere with their nervous system. This will not interfere with the respiratory system. Under that circumstance, can we accept in policy for people to use, let's say, HPV or coronavirus vaccines? This is the kind of, now you understand why we try to make this significant level so small. You know, when we talk about statistics in this class, we talk about significance level, people take it as a joke until it comes home to roost. That all these girls we have now scheduled for HPV vaccination, nobody is giving us a clear data from clinical trial that this vaccine we're giving our little girls will not affect them in future. Can we then have that policy? So when it comes to hypothesis testing, have a policy mind such that your antennae is always raised when you feel something does not meet the standards that are set, that are preset. I'm afraid to say I've done a lot of COVID research and written widely about it. But I have received a few calls, not a few, many calls from people saying, my relative was traveling from whichever country, which country, they collapsed at the airport and died. Or somebody collapsed at home and died. And they're trying to relate this to COVID vaccine that they received. And nobody is writing about it. Not even the Ministry of Health is trying to investigate. When we know that the vaccines we are using today, that were used during COVID, went through what we call emergency approval. Emergency approval means if the testing was to be done, first tried on the guinea pig kind of experiment, tried on rats, then they did clinical trials on humans, then tried to use it. Instead of going through, they went directly to humans. The other thing we don't know is that under Gavi, there is there's a no cost clause which says if anybody who used COVID vaccine has adverse effect that incapacitates them, it is the state party that should make that case and claim for their compensation. So I'm saying this because I want us to understand how significant hypothesis testing is. So new drugs are being introduced into the market every now and again. Some doctors are being given rebates. If they recommend this drug for you, they get rebates. You might find that you're going to the hospital. You don't have cancer. Maybe your relative has, but there are other treatments. Then this person describes very expensive drugs because the manufacturing company gives them rebates. It is this hypothesis testing that protects us as citizens, as consumers, as users of commodities from being harmed by the manufacturers, from being harmed by the drug companies, from being harmed by even the manufacturer of vehicles. The other time, Toyota recalled so many vehicles that were taken to the US when most of them were found faulty. We don't have such standards in our country. But it is this hypothesis testing class that when we attend it, we have a policy inclination, that we question the data before we pass a legislation or a policy on vaccinating young girls with HPV vaccine. We want to see the data from clinical trials. And we call an expert to interpret for us this data before we harm our children. That is how significant hypothesis testing is. Are we together?
Yes, we are.
Thank you, thank you. So this is why we are talking about type 1.
We are together, Prof. The one question that I may want to follow up there is into how you're explaining the importance and the severity of type 1 error. Looks like it's also very important to look at how we phrase the null hypothesis, because then it means in the HPV situation, for example, the null hypothesis must be that HPV will not adversely affect young girls in their adulthood or later ages. So that becomes our hypothesis. For our type 1 error to be severe, the hypothesis must be must be a statement that favors the outcomes of the HPV vaccine on girls. Because then if you say, if your hypothesis is the null hypothesis is opposite, which is that HPV vaccine will cause adverse effects on girls in their adulthood, then refuting that null hypothesis might actually be a good thing to the country, and therefore the type 1 error might be a good one. I don't know if I'm stating it right, but I'm just thinking about the designing or the stating of the null hypothesis.
When it comes to matters like new vaccine, this is how we state the null hypothesis. The use of HPV vaccine on school-going girls will not have adverse effect. I might even add, now and in future. At least giving allowance for the injection site pain. You know, when you are injected, the site where it is injected, at least you feel some pain. That the null hypothesis, H0, the use of HPV vaccine on school-going girls will not have adverse effect on them now and in future. That is the null hypothesis. The alternative hypothesis, which is either HA or H1, will go like the use of HPV vaccine on school-going girls will have adverse effect on them now or in future. Now or in future. But the other one was now
Is that a rule,
in future.
Professor Shem, is that a rule or is that the preferable way of stating it? Because I think that for someone who has not done research and statistics to the extent that you have, both of those statements could actually be a null hypothesis. But I just wanted to understand, is there a rule that governs the direction of the statements that we put in the hypothesis so that we can be able to sustain the argument that type 1 error is a more severe error than type 2 error?
Depending on the type of research, you realize that there is a reason why you take your protocol to ISAC. And there's a reason why, because you are going to deal with human beings, you also need ethical clearance, both from NACOSTI and ISAC. I sit in the ISAC of Jaramogi Oginga Odinga Teaching and Referral Hospital, where we review protocols that are brought there. And when it comes to medical research, the rules are extremely, extremely stringent for the following reasons. Some of those interventions cause irreversible changes in our bodies or in our lives. And so we must make it as stringent as possible. So even when you are, for example, there was a study being done by Cambridge, and it was a split site. And both the protocol that was used in the UK, and they wanted to adopt it for use in Kenya. So I was one of the people who interviewed that protocol. We looked at the compensation. If this intervention causes adverse effect, what are the responsibilities of the researching organization? Other than treatment, if the treatment can be done, if it is a short one, or compensation for this. And this is why the vaccine no clause said that if anybody became incapacitated because of using this vaccine, they should be compensated. Anyway, by the way, I've never had anybody compensated in my country. We are busy sleeping instead of reading what is really relevant. So the importance that is assigned to medical research is more stringent than all the others because of the irreversible impact that it can have on our lives. So, as a rule, it is whatever it is that we can do to make it even more rigorous, more stringent, we do it. So including framing the hypothesis. We don't leave anything to chance. HPV, administration of HPV vaccine to school-going girls will not have adverse effect on them now and in future. And it is for that that we have what is called cohort study or follow-up study. If, and we give these patients identification, unique identification number, we don't write their names. If we find a protocol where names are written, there's no protection, confidentiality, that is automatic rejection. So if we must have a study where patient X, and there's so many X's, are followed over a period of time, even 10 years. Like if it is given to 13-year-old girls, you should follow them for another 10 years when they're getting married to see how many of them there are having children or are not having children. Before this is allowed, this should be done, if it is clinical trial, this should be done before a blanket vaccination, uniform vaccination is done. Now, what happens, I'm not afraid to say this, what happens is that most of the drugs that come from the Western part of the world, they take it through the guinea pig trials. They try it on rats and things like that. Then when it comes to clinical trial, they want to go and try it in Congo with the humans, or they come to try it in Kenya. There should be a clause that it is tried first there before it is tried here. Because if it develops some adverse effects here, they're not going to use it there. No, we must take hypothesis system and hypothesis testing very seriously for policy reasons. I don't know if that brings some understanding, Dr. into that.
It does clarify it a lot. Thank you so much.
Now, you will appreciate this class if some of your next of kin had COVID and they continue to have long COVID. This is when certain symptoms proceed after 4 months and they're still continuing up to now. Then we'll appreciate the need for hypothesis testing in clinical trials. So we have agreed that type 1 error is rejecting null hypothesis when it is true. And type 2 error is failing to reject null hypothesis when it is false. We fail to reject it when it is false. In law is finding an innocent person guilty, or that is the type 1, type 2, freeing a guilty defendant, that is type 2. So these are the calculations that we are doing here are secondary. The most important thing here is to understand how to write your hypothesis, how to avoid the nuances of type 1 and type 2 error, and the philosophy behind hypothesis testing. these are the kind of discussions that you should be having at PhD level, because by being in this class, you are an authority in this country by the level of education. And therefore, the well-being of others depends on the decisions and your knowledge, the decisions you make and your knowledge about that decision. So I was giving some examples on how we can use some tests in quantitative to test hypothesis, like the one on my screen. No, before we go here, have we understood do we have the contextual understanding of hypothesis testing and its implications? I do not want to go into this if we have questions regarding your work as well. I will take your silence for consent. The other time, Millie told me that statistics is interesting until we start calculations. Are you people dead? Nobody's even talking. Okay.
We are here.
We are alive. We are alive.
Okay.
Okay. We are fearing the calculations.
No, these are very simple. This is just to understand a little bit of hypothesis testing. So,
Professor, maybe I can say it that from my understanding, I think even in the legal field, we have similar concepts, just like you say. For instance, in criminal law, to find somebody guilty, it has to be beyond reasonable doubt. And but beyond reasonable, we don't say it's not an absolute, it's reasonable doubt, because there will be some reasonable doubt. Like the case that you are saying, there's a similar case that I saw where somebody was murdered and people gave a clear description of the person who murdered him, and they even got the name. And so the person was found, it fitted the clear description and the exact name. But almost 50 years later, when DNA was done, they found somebody with the same features, exact same names. So that gives room for the 0.05 that you are talking about, that they did everything they could. And in the circumstances, everything was pointing to this guy. But now when you go to civil law, you will award damages, or you'll make a finding for the plaintiff on a balance of probability. So probably not. So I see actually the second one as going through maybe not. But the first one is beyond reasonable doubt. I kind of used that to make it easier for me to understand.
Yes. Thank you. This is the basis where those legal concepts, this is their statistical anchor, if you allow me to say so, because it's a game of probability, probable or not probable. So all of us are statisticians without knowing, but we are. It is wrong for us to talk elaborately about hypothesis testing, including the clinical trials and things like that, and leave the class without calculating anything. And we all have our calculators. So there's a question here we want to handle. It's a one-tilde test. Del Monte Juice Processing Company claims that their packet contains 3 liters of juice. A sample to be tested contains 36 packets. The trading standard officer would like 99% chance of not taking action against the processor for underfilling. The population standard deviation of the bottle is 0.18. The sample mean is 2.9. Find the standard error. Not standard deviation, standard error. The difference between standard deviation and standard error is this way. Standard deviation is how far an observation is from the mean, the difference between mean and another observation. Standard error, on the other hand, is in a population of 1,000 people, 1,000, then I decided to have sample of 200, 200, 200, 200. Then each of them, I get their mean, I get their mean, I get their mean, I get their mean. So standard error is the projected variation, the expected variation that all these means from sample one, because if they're 1,000, then each sample has 200, those are 5 samples. And each of this sample, the variation that they will give me from the true mean. The true mean is the mean of the population. But each sample has its mean. So my expected variation from the true mean is what we call the standard error. So most people confuse standard error with standard deviation. So in this case, we are given everything we want. We are given standard deviation. We are given the mean, the observation, and all that. So if you want to calculate the standard deviation, the probability of rejecting is observation minus mean over standard error. Here our Z is, I would like, let me try to see if I can use the blackboard. I should stop sharing. Use the whiteboard. So the probability of not rejecting the packets from Del Monte, where Z equals to sample mean minus population mean over standard error of the sample. That is the way of calculating that. Now to rub it. And this is the most interesting part. Now, we have to find the standard error to calculate it. You can use this pen. Standard error is given by standard deviation over the square root. It's still rubbing. Standard deviation over square root of the sample. In this case, we are given the observation first to be, we have the following values that we are given in this example. We have the mean, which is 3. Let me just write it somewhere. Mean, population mean is 3. They told us that every packet has 3 liters. Then the sample mean, which is 2.91. Then the sample size here is 36. Significance level here, we are given 0.01 because it was 99%. And standard deviation, we are given to 0.18. So for us to find the standard error, which is the standard deviation over sample size, sample used, which in this case is 0.18. 36. Now, if you have your calculator, what would be the value of that? Because the standard deviation given here is 0.18, and the n, which is the sample size here, is 36. If you calculate that with your calculator, what will be your answer?
Is it 0.03?
Yes, thank you. That's the correct answer. So our standard deviation is 0.03.
Is it standard deviation or standard
Standard error, sorry. Standard error. So now we have to calculate the probability given by Z equals to the sample mean, which is 2.9 Is it 2.9106? With calculation.
2.91.
1 minus the population mean, which was 3, over standard error, which is 0.03. What is your answer? You have a calculator. Anybody who has found the answer?
-3.
-3.
Okay. So our Z there is -3. This is a one-tailed test where our Z value is -3. So we go to the Z table. We go to the Z table and try to find it. But you can find your Z table online. Now, let's project the online one. Let me stop sharing and look for the online. Let me share it now that so now if you look at -3, so one-tailed test. -3 is 0. If you look at it across, 0.0135. So
Just a question, Professor.
yes, please go ahead.
Now, which is a legit Z tables? Because mine says 0.0013.
Yes, it is 0.0135.
Oh, so 5 doesn't matter.
Yeah, it is 0.03.
Okay.
Yeah. So if we round
Prof,
it off,
even mine is indicating that, though I have no clue what we are doing.
We are finding probability of rejecting the Del Monte fruit juice package. They told us that one packet contains 3 liters of the juice. Then they have selected 36 packets. We have selected 36 packets of that of Del Monte juice, and we are measuring to see if they are significantly different or it is what they have told us. So we have used our formula, which is the sample mean minus the population mean, that is 2.91 minus 3 over standard error, which we just calculated. And that is the value of the probability. Then what the value we get is Z, is the value of Z. Now Z is the probability in a standard normal distribution. So we get that probability. So what we have got is that the probability is 0.013. So we fail to reject the null hypothesis. They say the hypothesis was 0.01. Let me see. In fact, let me share what the hypothesis was. This is how we do it quantitatively. So according to them, their H naught was either it is equal to 3, one packet was either equal to 3 liters or more. They told us that each of them, so we will only accept if it is equal to 3 liters or not. Otherwise, we reject. So we reject when it is less than 3 liters per packet. And after our calculation of the standard error, and we calculated the Z value for that and found to be 0.0313, then we fail to reject the null hypothesis that their packets contain at least 3 liters of juice. So that is how we use the Z table. You see, if you, because it is a one-tailed test, it is towards the very end. We share the whiteboard again and say what one-tailed test is. Whiteboard. Let us clear this. But from today, I request you to be very attentive to some of these drugs and vaccines that are being imposed on us, because we must have the tools to verify that what we are being told is true. So in one-tailed test, The normal curve is somewhere like this. Like this. And this is the zero line. So the whole of this is 1. If this is a probability, it's 1. But our 0, the shaded region, is the probability of rejecting, the probability of rejecting the null hypothesis that Del Monte packets contain, a packet do not contain or contain liquid less than 3 liters. So this is where I find 0.013, this shaded region. So this is what we mean by one-tailed test, where this is the mean. Mean is always 0 in standard normal distribution. So the area under curve is always the probability. So the probability of the section of this under curve where we are is 0.01. So we fail to reject the assertion. If this was a two-tailed test, we would also do this on this other side, because this is negative, that was -3. This would be +3. And this is also will be 0.013. Then we will add this. Then we'll find the probability to be 0.026. So if it was in two-tailed test, we'd reject it because they gave us a significance level of 0.01. But here, our P has come to 0.026. Under two-tailed test, we would reject the null hypothesis. So in one-tailed test, we would accept it. But in two-tailed test, we would accept it. So what I'm saying, under clinical trials, we will not accept, or we should not accept, vaccines trial whose data has been used one-tailed test. We want two-tailed test because this is a matter of life and death. So the two-tailed test for clinical trials is better, more stringent than one-tailed test. So I will share these notes with the class president. You can try the next example on your own. You can try the next example on your own.
Mwalimu, I had a question.
Just go ahead.
Yes, what is the level of significance in that example you've given?
0.05. No, this one we have done is 0.01.
0.01.
In this one. By the way, okay, Victoria, you have a question. I need to explain something, the difference between confidence interval and significance level. I will explain that after your question, Victoria. Go ahead.
I wish you would have explained first, but let me just ask and then you will decide. So my question is, as regards the previous session on R, and I've also heard you talk about ANOVA. Now, for those of us who are finding it so difficult with R, what would you advise, especially if you know a little bit of SPSS? Is it just for us to learn, or what is your take on SPSS, especially when it comes to our research?
Okay, I will answer that question and then go ahead to explain the difference. The reason why the advantages of using R, as you have seen, it is free. Or has any of you paid to use it? It's 100% free. 2, it is rigorous. It is code-based. It is not command-based. There's very little difference between Excel and SPSS because both are command-based. You just tell them to do this, you command them to do this, and then they do it. R is code-based. In this generation and this century, people are moving towards AI. R and Python are more scientific, but you must understand that R is the grandfather of Python. R is more superior to all those other data analysis software. It is free. I don't know if you go online, you'll check the prices of SPSS. And is a way of doing things in the 21st century with IR4 revolution, Industrial Revolution 4, which is on the Internet of Things. If you buy SPSS, they'll give you the number of users who can use that, license certain number of users who can use it. R does not do such a thing. Any number can use it that much. I don't know about you, but I know about myself. When things are not going right, I tend to be happy because I know I'm on the right track. It is very challenging. It's actually very hard on the ego. You know, you call yourself a professor and then this thing is giving you a problem. It also brings what we call imposter syndrome. I am supposed to be an expert in this. Why is it giving me a problem? That is a good thing. Even in your PhD, when everything is going smoothly, you're not doing the right thing. Something is wrong somewhere. So, yes, most of your data analysis could be done by SPSS. That would require a license. For how many of us are here? In this class, we're around 54. Sometimes it goes up to, like during the VC's class, I saw it reached 74. Those are not a lot of licenses to use SPSS. This is only, I thought that instead of struggling to get licenses for everybody else, let me use what we can use freely. Being a problem solver and a researcher means you start with what is available before you ask for help. This is what is freely available. And I really pray so much that you enjoy it. The next time we are going to do ANOVA, where all those clinical trials. ANOVA is the tool that even supports clinical trials. And it has been used. I've used it severally on such studies. I don't know if that answers your question.
Yes, it does. But that means we'll be looking for you personally.
All those people who have looked for me have found me, including Peter Wasike, who flew all the way from Lamu. He came and found me in the office and we solved his problem. So if whenever we're having classes, especially this ANOVA thing, we are able to go procedurally, most of us will understand and appreciate it. And I'm available for consultation. My father was a teacher before he became a bishop and died. I am also a teacher. So I'm available for consultation. Now allow me to go ahead and explain the difference between significance level and confidence interval. Significance level, most of the time 0.05, is the probability we allow for anyone to commit type 1 error. Significance level is the probability we allow for someone to commit type 1 error. For you to jail an innocent person, 0.05. For you to give us medicine, inject our girls with HPV, we are giving you 0.01 of error in that kind of clinical trial. For you to inject us with COVID vaccine, for which we stand to sue many drug companies, we need field data, clinical trial data, showing that it is 0.01 significance level. So it is the allowance, the probability we allow you to commit type 1 error. Confidence interval. Let's say in our class, in this class, if we take our heights or our weights, we take the lightest person, the class, and take the heaviest person in the class. Then we select people at random and measure their weights. Their weights, if the lightest person is 60 kilograms and the heaviest person is 200 kilograms, then we select any member of the class at random. They will always fit, their weight will always be between 60 and 200, whoever we choose. So in that way, we say we are 95% confident that the weight of any member of this class chosen at random will be between 60 and 200 kgs. That is the simplest understanding of confidence interval. It is that simple. Are there further questions? Victoria or Charity, any question? Oh, Dr. Livingston, please, go ahead.
Yes, thank you, Prof. I think, I don't know if the map came after we have really done a lot of long sessions, but I just wanted to understand then application. Some of us are in theory. The application of this, will we be doing these calculations or did we get it through a tool?
I didn't quite get that question properly. Please repeat.
Yeah, it's scaring the way we are going with mathematics, especially some of us who are theoretical. So we are asking in terms of application, how then do we, how do we get this applied in what we do? As we do our research, will we be required to do these calculations or there's a tool?
You realize that from the time we have been doing the quantitative here, we have been using a software that automatically calculates things for us. And for those who will be doing quantitative or mixed methods, you'll be analyzing your data, your quantitative data. Some of these things are already fed into the software that is analyzing your data. For those who have come to our office in Valley Road, and we have run R with you, you'll realize that it automatically gives you the 95% confidence level, significance level. It automatically does that. That is how best I can respond to that. And you've also seen how beyond class, this knowledge of hypothesis testing can help you in policy and in general knowledge of what is going on around you. Like right now, people they want to inject HPV vaccine on girls in primary school, which we have not seen any data at all on clinical trials. And they have not involved or communicated anything on the efficacy and adverse effect on this. So applications here are many, many.
Mwalimu, I wanted to ask.
Yes.
Why does the confidence interval always appear at the point of the mean, at 0?
Does it appear at 0?
I mean, it is drawn from there upwards. I don't know whether I'm asking the correct thing, but if you look at what you have drawn, I mean the line at the middle
is 0. This is the mean.
Yeah, that is the mean.
Yes.
And that is the point where the confidence interval is. Why does it usually appear there?
Like if you look at the edges here, the area under the curve is the probability, which is 1. Probability is 1 or 100%. Then standard deviation are how far observations deviate, vary from the mean. That could be standard deviation 1 on the left, 2, 3, 4. Then on the right, this could be standard deviation, just like that. But the percentage of the confidence, of the significance level is always on the extreme end because it is small, very, very small. The bulk of this is within the larger accepted level. Now we don't accept this. We can only accept this for our generalization. You see, when you do research and quantitative at that, you want to generalize your results so that if it can be replicated elsewhere on this planet. And this helps us in generalization. But look, however much you replicate this kind of experiment, you will end up with a probability of error of 0.01. So this also aids in generalization of results of experiment. But mean is always the middle. When somebody is explaining what the figure tells you where the mean is, it is easier to know. The mean is always in the middle. So we are not, we are just showing this to show you where the mean is. So when you are talking about one-tailed test or two-tailed test is on the far end. Both of them are on the far end of the area under the curve, which is far end or away from the mean. So mean is just like a beacon. Like if you bought land elsewhere, somebody will, you put a beacon. At least there would be 4 beacons at both ends if it's a rectangular plot. So there within, you can from one beacon to another. Now this is a beacon. Mean is more of a beacon in this kind of circumstance.
I have a question, Professor.
Go ahead, please.
Yes, now mine is as regards to the hypothesis and the research. So this is what we were told, or this is what I know. Let me just speak on my behalf. I know that for qualitative, we have research questions, and for quantitative, we have the hypothesis. Now, this is my dilemma. I have my research questions that come from the objectives, and then from those research questions is where I've drawn also my hypothesis. Is this okay, or now do I remove the ones that are for hypothesis and remain with, because mine is a mixed method research, do I remove the ones for hypothesis as questions, or do I just, so that I have maybe 2 questions on research questions for the qualitative, and then my 2 portions of hypothesis, one on behavior, the other one on institution, and or do I just leave the research questions as is, and then I put my hypothesis after, because that's what I've done for now. Thank you.
Okay, thank you for that question. Research questions should remain as is. We always align hypotheses with our objectives because in the research papers that you're supposed to publish, at least 2 before you graduate, which we are very ready to help you publish. Each paper is published along each objective. So if you have 3 objectives, you're very lucky, you can publish 3 papers. But research questions are also aligned to the objective. You can find one objective has like 5 questions, which is okay. But one objective, one hypothesis. By one hypothesis, I mean one null hypothesis and one alternative hypothesis for one objective. That would enable you to, for each objective, you publish a paper. For each objective, you publish a paper. When I was doing my PhD, I had 3 objectives. We were required to publish 2, I published 3. If you have 2 or 3 objectives, you're lucky, you can start building your body of work as fast as possible. And by the way, I might say this, you don't really have to wait until you have you've done your research to publish. Do you know, out of literature review, you can publish a paper on a review. Like for example, in Millie's case, out of your literature review on CDF, you can publish a paper titled the exploratory review of CDF administration in Kenya. An exploratory review, which means you have reviewed all the papers, you've synthesized them, now you publish. That would be a big advantage to us in this class if after our literature review, we just try to publish a review. It's not a must, but there's a possibility. Somebody can do a thorough review of literature and give an exploratory review of your topic that you are dealing with. You've not done any research, you've reviewed, and you can publish your review if it follows certain criteria. And reviewing is very, very easy.
Just to add, Daktari, now
Go
that
ahead.
you have talked about the objectives, that's very important. For example, your research has like say the main findings, like the demographics. Now, before you do the actual deductions on the findings, you know, those ones are the ones that you use for all the objectives. Now, remember this is for example, now I have this is the main study, the main findings on the studies, like the core of the study. Then I have published one objective. Then now I publish the second objective using that data. Will it be accepted? And then the other question is this: I want you to clarify on the exploratory review you have just spoke about, because we were talking about it with my colleague. Do you publish a proposal, or you do a publishing of the systematic review or the exploratory review? I hope I'm not confused myself. I hope you get my question.
Yeah, I get your question. First, if you collect data, you can publish many papers with that data depending on the angle you take. You can tweak and publish in one direction, tweak, and provided you're not saying the same thing in all of them. Each of them is giving a different perspective. That's allowed. you don't publish your research proposal. What I have said, I don't know if it was clear enough, is that you do rigorous literature review. For example, you have a topic. Let's say one that is most published in this forum is Millie's topic. Then she goes around and does thorough, rigorous literature review. Then she finds certain gap, or even if there is no gap, then she decides to write a journal article, a meticulous one, on maybe exploratory understanding of CDF mechanization in Kenya. And goes away and all the, write in a very nuanced scholastic language. It can actually be even 2 pages. I've read reviews that are 1 page, but thoroughly reviewed thing. That counts. The requirement is that you publish 2 papers. That counts. But you don't go ahead and publish your proposal. No. That does not count. So you review your literature, you synthesize the information therein, and expand. And in that kind of writing, clarity is very important. Is what you are writing, are the ideas coming out clearly? So you have no excuse of not publishing or not thinking to publish. I want you to be stronger, bigger than your excuses. We will be ready to help. Yes, Kawira, you have a question.
Yes, I just needed clarification. While I understand that you cannot publish a proposal, can you publish then a research protocol?
But a research protocol is not far from a proposal. You can't. Yeah, there's people who are published, but it will not count for your publication in advancement to your PhD. No, it won't count.
Okay.
The protocol is well, there's no big difference between protocol and a proposal, actually. But except that research protocol, we're saying clearly what you are going to do, how you are going to do it. It's just the same thing. You don't publish that. Just you can start publishing from exploratory understanding of certain things. I have published something on an exploratory understanding of something. I see we remain 43 here.
Well, Prof, I was asking that in terms of a protocol, one of my most cited paper is a research protocol, and I wanted to find out if a similar thing is possible. But I guess I'll look for you for further discussions. Thank you.
Oh, okay, that's fine. That's fine. If there are no, there are some questions in the chat, and there are many. I've not read any of them. So I want us in this class to be critical thinker and people who take action. When you are in this class, one of the things that should occur to you, that you have a responsibility to the society, because you have had, God has given you the grace to explore information that many people do not have. And what I do most, I think most of my advances in academia has been because I take action. When I see something and I hear people complaining, I don't get engaged in those discussions. I just go into my library and research and publish something about it. So you don't argue with me, you argue with my publication. So taking action is what gives us advancement. Nothing happens in life, academia, or industry if we don't take action. Even biblically, we know that the Israelites left Egypt, but they had to carry weapons. It is God who took them from Egypt. God could fight and kill people on their behalf. But why did they have to fight? I mean, most of them also died there in the fight, yet it is God who brought them. So my understanding of life as it is action, is what separates wheat from chaff. Action is what moves you from level A to level B. Get into the habit of arguing with authors. You buy their books, you argue with them. You'll find you have a lot of advancement in knowledge and everything else. So I am thinking in this class, we could have people who are either in academia or in industry. They feel they have a lot of information, but they don't know how to publish something. We'll be available for consultation on that. Because unless you publish something, you're not an authority in that area, no matter the information you have. Because people, when you are invited elsewhere as a speaker, people will want to see your works. And people interact more with your works than they interact more with you. So I want us to have a culture of writing and publishing. In fact, by the time you are graduating, you realize you don't have the bar that is set for 2 papers to be published, or even published for. Just that's what I'm thinking about. I don't know how helpful that one is, but we can try. Aren't we supposed to end this class if we have no further questions?
Prof, allow me to take you back a little bit.
Yes.
We'll go back to where we were talking about the type 1 and type 2 errors.
Mm-hmm.
Yeah, and I had a little pushback with regards to the seriousness of which is the worst error. I was just thinking that, and I stand guided that it really depends on the context. I think one of the examples, of course, you started giving us an example in the judiciary of convicting an innocent person. But in a scenario where maybe somebody has HIV/AIDS and you miss getting the actual disease, so that's a false negative, meaning the person will go being happy that doesn't have the disease. So you can imagine the impact. So I think it really depends on the context, whether you're in judiciary, whether you're in medical field. I think even in your scenario in the academia, you can think of publishing a paper where it's been really influenced. There's a lot of bias, and you know that. So that is the first question. The second one, I wanted to understand the difference, or if there's any impact between the errors, the type 1, type 2 errors, and the tail test. Are they related in any way? Thank you.
Okay, thank you very much, Simon. Type 1, type 2, and significant level, significant level of significance are related. Whereas type 1 error is the probability of rejecting null hypothesis when it is true, type 2 error is failing to reject null hypothesis when it is false. And the one-tailed test is significance level, which is the permitted probability of committing type 1 error. Are you seeing the relationship? It can be a little confusing. I will
Yes,
repeat.
Just come again.
If you have somewhere to write, I can
Okay.
repeat, you write.
Sure.
Yeah. Whereas type 1 error is rejecting null hypothesis when it is true. I repeat, whereas type 1 error is rejecting null hypothesis when it is true, type 2 error is failing to reject null hypothesis when it is false. Type 2 error is failing to reject null hypothesis when it is false. And level of significance is the allowed probability of committing type 1 error. It's the allowed probability of committing type 1 error. Succinctly, that is the relationship.
Okay, so meaning that I was so meaning if you decide to do a one-tailed test, that's if you're looking at something to increase or decrease, which is directional, it means that usually you'll have a lower type 2 error. You'll have a lower type 2 error, which is a higher statistical power, because you're focusing on one direction, right?
Mm.
And the
That's
inverse,
correct.
yeah, and the inverse for type 2 for two-tailed tests. Thanks.
That's correct. Yes, John, you have a question.
Yes, Prof. And firstly, thank you so much. I think this has been quite enlightening, as all the classes. So, and I don't know if I'm jumping the gun here, but I was just curious to ask, for instance, now we are beginning to write the chapter 1s and all that in the process. So I was wondering, will there be maybe a situation where you can take us through, for instance, so that all these things now we can begin to put them into perspective. So I have written my my proposal. Now I want to go collect data if I'm quantitative, if I'm qualitative person. Then I come back. I want to analyze. I apply these means this way. I check the standard deviation. I use R. Then I interpret this data. I don't know, maybe there is. I know I bought the book, but I haven't read. Maybe it's there. But I am just curious to ask, because that will be really helpful for us to begin to see now to put ourselves into that angle where now, okay, I know I'll go collect data. This is how I'll use R. This is how I can do the mean. This is how I'll interpret the tails and everything. I don't know if maybe I'm asking too early.
You are not asking too early. I want to illustrate this. You may not be a historian. I also didn't do history. I am a scientist. But in history, Africa has been beating Italy, every war they have had with Italy. There was once a general called Hannibal, who was from Carthage, modern-day Libya. And he took his army all through the mighty Alps mountain into Italy, and they met with the Italian army led by Scipio. Scipio, that was way before Jesus Christ came. Scipio was the greatest general of all time, at least up to that time. Hannibal was from ancient Africa, defeated Scipio hands down. Historians have been wondering, how did this happen? This is what happened. Hannibal had the end in mind before fighting the battle, and he had put every plan in place, even how they were going to create, to circumvent the mighty Alps and go into Italy and fight. It took them years, but he had that in mind, and he delivered. He defeated Italy, because from the beginning he had end in mind. So if you're beginning your research, you must have your end in mind and clear processes and milestones. Because if you do not have milestones and a plan on when to achieve them, you might do your PhD for 10 years. But if you have clear milestones and plan on which you are holding yourself accountable, you can do it. I was giving that illustration because Rome, the ancient Rome, was a superpower in the known world at that time for a very long time. And it was not known how Scipio could defeat, how Hannibal could lead Carthage to defeat Rome in an open battle. But because of his planning, he did perfectly well. Of course, the long and short is that during that time in Rome, if you are going to war, you had a ring, like a wedding ring, but each ring had an inscription of you, your name and things like that. When all the rings were collected with the people that Hannibal's army killed, there were 50,000 rings collected. Scipio took the rings and went and started reconstructing the army, which was decimated by then. When they later met, they again beat Hannibal. Because Hannibal's purpose here was to defeat Scipio, which he delivered, and delivered very well. Then he relaxed. So that's why he was defeated in the next. So the object of that illustration is, your object now is how fast you can complete your PhD, which you will deliver. I'm sure you will deliver. But remember that every PhD is a researcher. You don't stop, you proceed. PhD is a training. Right now you're in training, which you must deliver, you'll go through, then now you will go to the actual work. So 5 years down the line after your graduation, you should have produced some of your best works. This is training. So please do everything possible. Plan well in advance so that you have the end in mind. So I am requesting you to have a schedule, a proper PhD implementation plan, holding yourself accountable. You write it clearly down in your book, any exercise book, notebook, whatever it is, and evaluate yourself every single day. You will break it down into small bit. Like if it is just chapter 2, which I've had our wonderful VC telling you that you need chapter 2, you can commit yourself to be writing 1 paragraph every day, just 1 paragraph. And I think I've told you that in research, you can read 10 journals to write only 2 sentences. But it's a very beautiful, well-capturing sentence. So if you hold yourself accountable that if each day you're writing only a line, in 1 month you've written 30 lines. That's a lot of lines or sentences. So I'm trying to make you see how you can make progress without being seen to struggle. But you only know your challenges. What I do myself, even today, every single day I must sit down in my library and do something, even if it is only 2 hours, or if it is only 1 hour, but I have to do something. So you must have your time to do something, to write, even if it is only 1 sentence a day, because we want you to graduate. That is all. I think we can end the class unless there's a compelling, burning question.
Thank you, Prof.
Okay, everybody, God bless you.
God bless you.
Thank you, Prof.
Yes.
Thank you.
Bye-bye.
Bless
Thank
you
Prof.
too.
Thank you.
Thank you.
Thank you, Prof.
God bless
Have a
you.
good day.
You too.